think everyone should take a deep breath. Get some oxygen back in, because you've heard just a hurricane of information. But now we have the opportunity for a question and answer session before you get released to have some more coffee. Do we have any questions from the floor? Please.
Andy Lembrake from Energy UK. Is the climate modelling that's being done under this project consistent with that work that's being done to produce the climate projections 2018?
Not really. Why not? Because it's an extension, if you like, of what was done to UK CP09. So it's sort of like, it's heading in that direction, but because we didn't have access to all the modelling we currently have in the Met Office, we'd have had to started our project 4 years later. So, yeah. But in terms of the range of possible futures, we're looking across a very wide range of the drivers of the climate of the UK in terms of the different amounts of warming and the sort of the patterns of change you get from driving the UK climate. So it is a pretty broad range. So that's how it is an extension on 09, but it isn't quite up to UK CP80.
Question, just you will respond to that, Joe.
If I might just dive in as well. As we looked this morning, the morning is full of trade-offs. UK CP18 and these with their own results represent two different approaches to another trade-off, which is the computational modeling trade-off. So UK CP18 is using a newer and higher resolution model, but what that means is that you can't do very many runs with that model. Richard will be able to tell us the exact number, 15 or so?
Yes, of the details.
Of the details.
UK, yes, of the order of 15, whereas of course we've got 10,000. So in terms of being able to do something on risk, then we've got something which is a better resource, absolutely. And especially if you're looking for tracks which are long period things for which you need big samples to get anything specific.
Yes, I just want to mention actually, because I don't think it was flagged, that the reason why there's been references to weather at home is because it comes from a citizen science outreach element where people with available computing power use it to run these climate sequences. This isn't just for Marius, but it is part of the climate team at the Environmental Change Institute. So that if there was a reason, if you were wondering why it's called weather at home, it's just that kind of citizen science approach. Oh, we have another question online.
Yeah, hi, I was actually about water quality, but there's obviously some really good stuff about water quality impacts to do with drought on river flows, but I just wondered if anything has been looked at for groundwater quality impacts?
Well, groundwater is kind of incorporated into the Inca model in a fairly simplistic way. So groundwater kind of definitely interacts with water quality, and it's the sort of tranche of water that comes through the system, especially in the chalk aquifer. It's very important in terms of supplying deeper groundwater into the Thames. So that's sort of incorporated in, and water quality goes through the groundwater system as well. So it's built in. We haven't put a massive amount of effort into actually modelling specific groundwater locations in great detail. That really wasn't part of the remit of the project.
Thank you for that. I'm going to follow up, Paul, sorry, with another question that was put on Slido, which is, has there been any modelling of temperature?
Well, the model basically makes use of the data that comes out of weather at home, and part of which is temperature.
Water temperature.
Yeah, but we feed that through the model to say how water temperature will change. The water temperature is driven by the air temperatures, basically.
So there is?
Yeah.
Through Inca?
It's used within Inca to actually to say what the temperature of the water is, and therefore how that temperature affects the reaction kinetics happening in the river system.
Question?
To follow up on that, sorry. Can you talk about maybe using the local ground within London basis?
Good question. We are working in the Dales project with Thames 21 and modelling some of the London catchments, 3 London catchments. Started setting her up for those. Temperature's part of that model as well. We haven't really looked in detail at sort of groundwater components, temperature now.
Thank you. I've got a question for Vicky. The question is, will the CEH outputs be available to water companies to use?
Will be available on the CEH EIDC platform. I don't know whether there's any license restriction at all. I'm sorry, I'm not expert in that. I imagine if they're on a website, they're available.
Do you have any idea of when the outputs will be available?
We're starting to look at it now. I think it takes a while to get them all loaded, but I'm hoping they'll be done by Christmas, or at least some of them will be available by Christmas.
Okay. Thank you. Any questions from the floor? Paul?
Paul Hammett from the MFU. I was thinking about, we heard a lot about the River Kennet this morning. Are other rivers available? And particularly from my point of view in terms of the rivers that farmers rely on for extraction for irrigated cropping, how representative is the research that's focused on the River Kennet to irrigated cropping in the south and east?
Yes. The next session after the break will touch on agriculture.
I'm very well aware of that.
Yes. But actually, there was a question also about the different models used by CH and Bristol. So actually, can Gemma and Vicky, you could comment again on what other data sets are available for rivers other than the Kennets, one of the most heavily researched rivers in the UK, to answer the question, please.
We're releasing the liquid national scale 1 kilometre grids of roof flows and soil moisture for hundreds of years, and that gives you estimates of river soil moisture everywhere. Those are monthly data. We're also producing daily river flow estimates for more than 250 catchments for the past back in 1991 and for all the future runs and all the other home runs. So there's an awful lot available, which is why it's going to take us so long to get this on the data.
So the sort of recent historical unit at the moment we've only run for sort of 1961 to 2015, but that's for pretty much every gauged catchment in the UK. And then we also have some ungauged points that fed through Hannah's model as well. For the future, there's a slightly reduced set just because of, as Vicky said, the amount of information. So I think there's about 160 catchments at the moment that we run. And we're, as part of Endows, we're also producing sort of more of a common data set between all of the hydrological modelling approaches that have taken place through the Drought and Water Scarcity Programme. And I think that will be of the order of about 150 gauge points throughout the UK. So there is a lot of data. Gemma just mentioned Endows. Endows is another phase which is started already, and there is a specific presentation on that at the end of this morning conference, so you'll hear more about that. Torsten, did you want to?
Yeah, I just wanted to say that with respect to the catchment scale modeling, the main objective was not to understand the Kennet in great detail, but to have a catchment with particular hydrologic characteristics that are particularly difficult to model from hydrologic models, and see how we can implement these, for example, in this catchment, but with transferability to other places in the UK with similar type of characteristics.
From the Environment Agency, just wondering, you talk about transferring to other places and using that specific model package. Is there an aim to get these model packages you're using more out into industry? I mean, I know Grid to Grid is sort of a household name for us, but PHIN, is there any sort of industry or regulator intentions for these packages to be available?
Yeah, I think, with respect to the model we use at the catchment scale, I think that is a very complicated model and not particularly easily transferable. It was a test bed for us because it's so difficult to run. The idea is to take what we learn there and put it into the top model, for example, and have that the model that would be much more attractive, or Grid to Grid, for that matter, would be much more attractive for companies to processes, algorithms available, and then implement them in large-scale models, which would be attractive.
I'm not aware of any plans to do any more modelling. It's used operationally in the public testing centre, and maybe there's opportunities there that could follow that, but I don't deal with that work myself.
Okay, Phil, we have a question.
Yeah, I'm sorry about this, Helen, but it's actually a question on Alex's presentation, but it may be that Paul can pick up on it, I don't know. But it flashed through pretty quickly, but that final slide that you showed on the difference between the drawdown and non-drawdown effects under certain conditions, I don't know whether it was chlorophyll A or what was being shown at the time, did indicate that there were a number of peaks that occurred under the non-drawdown conditions that often meant that it was higher than under the drawdown conditions. And I just felt that that just illustrates that it's really useful to explore in more detail, well, what are the processes that are happening there, that it may actually be that sometimes your mean to slightly above mean levels could be higher under normal conditions than under drought conditions and so on. And I was just quite interested what was driving that in the reservoir itself. I don't know whether Paul's got a comment on that.
Well, I think that there are so many factors going on. I mean, it's also to do with what nutrients are coming into the reservoir to stimulate algal growth, and also the temperature and light conditions that affect the peak of the phytoplankton blooms. So I think there are a lot of variables that do control those behaviours. I think Alex's main point was that as you increase temperatures and you increase nutrients and drought conditions, you seem to see these increasing bloom sizes in the reservoirs. And I should imagine, and I suppose the other idea is that as you draw down the water, you've got kind of more stable conditions perhaps for the phytoplankton to grow, and again different nutrient conditions. So you're right, it's a very complex set of processes going on, and it might be worth asking Alex to kind of capture those key points.
Yeah, I'll certainly contribute to that. Really swiftly on it. Doug, would you like to ask the last question?
Quick one. There's been a lot of work looking at the climatology of the droughts in the 20th century and how those compare against various models. And we keep seeing these sort of nasty persistence effects over about sort of 12 months-ish, 12 to 18 months. And they make all of the worst droughts look quite high in probabilistic terms from the 20th century. I was just wondering whether there's, just looking at the results from ARIS, it looks like there are a few of those issues, despite all of the great work that's been done. Is there any advice about turning plausible droughts into droughts that people can then sort of start to assign probabilities to? I guess that's the big question.
Who would like to answer?
If you report to you.
I know, Did you have any points? I'm a bit stumped. I have to think about that a little bit.
Then that's quite a complicated question to answer when we're not really great. So how about
Okay, so from a climatological point of view, we can definitely do that. We can certainly, from our very, very broad range of either simulations of plausible pasts and also into the future, we've got distribution there, and we can look at how extreme those extreme ones are in terms of a return period or something. Yes, we can certainly do that. The thing that we are concerned about then is we don't have enough of the sample of the real world to be able to say how accurate an estimate that is of what the real world is doing, either it would do in the past if you had 2,000 years worth of past and what it might do in the future. But it certainly, we can give you a guide.
And I think, Doug, in a sense, what we've got here is about as good as it gets in terms of this multiple resampling of climatic conditions which are consistent both with what's in the past and with what climate models are telling us about what's going to be in the future. The other thing I'd add is that alongside that resampling of plausible climatic conditions, which gives us some basis for estimating probabilities, as Richard has said. We've also, in the hydrological modelling, been looking at the effect of uncertainty at that level as well. And so that needs to be taken into account when you're estimating probabilities too.
Thank you.